Welcome to our lesson on box and whisker plots. These graphical tools are widely used in statistics to display the distribution of a dataset through its five-number summary. The foundation of a box and whisker plot is the five-number summary, which consists of the minimum value, the first quartile, which is the median of the lower half of the data, the median, also known as the second quartile, the third quartile, which is the median of the upper half, and the maximum value. Let's look at how a box and whisker plot is structured. We start with a number line that covers the range of our data. The box in the middle represents the inner quartile range, from the first quartile to the third quartile. Inside the box, we draw a vertical line representing the median. Finally, we extend whiskers from the edges of the box to the minimum and maximum values. Now, let's learn how to construct a box and whisker plot step by step. First, we order the data from smallest to largest. Then, we compute the five-number summary: minimum, Q1, median, Q3, and maximum. Next, we draw a number line that covers the range from minimum to maximum. We draw a box from Q1 to Q3 with a line inside it at the median. Finally, we draw whiskers from the box edges to the minimum and maximum values. Let's work through a complete example using the following data set: 3, 7, 8, 12, 13, 14, 18, 21, 23, 27. First, we note that our data is already ordered from smallest to largest. The minimum value is 3, and the maximum value is 27. To find the median, we note that there are 10 data points. Since this is even, we average the fifth and sixth values, which are 13 and 14. So our median is 13.5. For Q1, we compute the median of the lower half of the data, which is 3, 7, 8, 12, 13. This gives us Q1 equal to 8. Similarly, Q3 is the median of the upper half, 14, 18, 21, 23, 27, giving us Q3 equal to 21. Now, let's draw the box and whisker plot for our example. First, we create a number line ranging from 0 to 30, covering our minimum and maximum values. Next, we draw the box from Q1, 8, to Q3, 21. We add a vertical line inside the box at the median, which is 13.5. Finally, we extend whiskers from the box to our minimum, 3, and maximum, 27 values. And there we have our complete box and whisker plot. Now that we know how to construct a box and whisker plot, let's learn how to interpret it. The position of the median inside the box tells us about the skewness of the data. If the median is closer to Q1, the data is right skewed. If it's closer to Q3, the data is left skewed. The length of the whiskers shows us the spread or variability in the tails of the distribution. The length of the box represents the inner quartile range, IQR, which contains the middle 50% of our data. In some box plots, outliers are shown separately as individual points beyond the whiskers. One of the most powerful uses of box and whisker plots is comparing distributions side by side. For example, here we have test scores from 3 different classes. We can easily compare their centers, spreads, and overall distributions. Class A has the highest median score, but Class C has the smallest inner quartile range, indicating more consistent performance among students. Box and whisker plots are useful in many scenarios. They help compare distributions across groups, identify outliers, and assess the central tendency and variability of data. They are commonly used in evaluating test scores, analyzing clinical trials, and examining financial data. To summarize, box and whisker plots provide a concise visual summary of a data set through its five-number summary. With just one glance, you can get a good sense of the center, spread, and skewness of your data. Thank you for watching. Now you're ready to create and interpret box and whisker plots on your own.